So, ladies and gentlemen, I want to take this opportunity to welcome all of you to the integer programming problem that we have for today. As the name sounds, it is an integer programming problem. Integer problem. What does that mean? What does it mean to have an integer? First of all, what is an integer? An integer is a negative or a positive whole number. That's an integer. 1 is an integer. 2 is an integer. They are not decimals. So an integer is a non-decimal number. And in this context, it's both negative and positive, but in this context, because of the non-negativity constraints, we're going to focus on positive whole numbers. Now, there are some situations in life when things are not practical to keep them in decimals. You might remember during the marketing optimization problem, where you have the TV, the newspaper, the radio, you realize that there was some of the answers, the optimal solution included 1.8, included 10, and some decimals. And you are talking about 1.8, radio adverts. It doesn't make sense. It's not practical. It's not practical to buy an aircraft, which is in total of 38.56 aircraft. It's not practical to buy 418 vehicles. Decimals don't matter. I mean, they don't make sense in this context. And sometimes there'll be the tendency to want to round up. The problem with rounding up is that it can cause a lot of problems. For example, if you round up profit, let's say the profit is 40.3 billion, 40.3 billion, and you want to round up, you just make it 40 billion. But what you've done is that you have thrown away 300 million away. That's a huge amount of money. So you have actually rounded down the profit. The same thing if it is cost. And the cost is 39.7 million. 39.7 million, and you make it 40 million. You have overestimated the result. So you tend to get suboptimal solutions, and this can cause infeasibility. So what do? What you need is a constraint that will force the model to have an integer. So you will incorporate that integrality constraint into the model. You are not just forcing and rounding them up, but you are taking care of every detail in the model so that the thing makes sense. That's the essence of today's lecture. So everything we are going to do is just like linear programming. The only thing we are going to add is the integrality constraint, integrality constraint. Okay, not integrality. It is integrality. Okay, and what does that mean, or how do you write that? All you got to do is to write int. After your non-negativity constraint, you add and int to indicate that it's an integer, and int. But you got to know that there are several kinds of integer problems. And we are going to look at some of them today. Okay? There are several of them. There are 3 types of integer problems. One of them is the pure integer linear programming problem. That one, all the decision variables must be integers. For example, suppose we are talking about cars, aeroplanes, and helicopters. You can't have 20.4 cars, 16.7 helicopters. So all of these are integers. The decision variables are integers. And then you can have a situation where all the decision variables are binary. For example, you have to set up a certain company And so the classification is in such a way that you either set it up or you don't set it up. The probability that a customer is going to default on the loan, either the customer defaults or does not default. So when you have a situation like that, that is a binary integer problem. And then you have the mixed. The mixed is where some of the decision variables are decimals. Some of them are also integers, but even among the integers, some of them are binary, some of them could be whole, and all of that. And so that's what we are going to be looking at today. Okay. I hope you all get a picture. And so I want to set the ball rolling and begin the greatest show of integer problem. All right. Now, let's take a typical example. Okay. And I want to just take a quick example by looking at this storyline. Agbala, owner of a machine shop, is planning to expand by buying some new machine presses and lathes. I wanted to just take the presses like you might call nika and lathes, any two machines. Presses, lathes. Straight away, you should know that you cannot have 2.4 presses or 3.8 lathes. So that is an integer, a pure integer being introduced it got to be in your mind. Each press will increase profit by 100 per day, and lathes will increase profit by 150 daily. So if we are to represent X1 by the number of presses, okay, if X1 is the number of presses and X2 is the number of lathes, okay, if we are to represent that, we are being told that profit will increase. So obviously this is a profit maximization problem. Profit will increase by 100 if we deal with the press, or by 150 if we deal with the lathes. Therefore, our objective function will be Zmax equal to 100x1 plus 150x2. That's what you have there. I'm sure you get a picture. So that is a straightforward way to write that. Now, according to the story, the number of machines Agbala can buy is limited by the cost of the machines and also limited by the available floor space. So one, we have cost constraint and then space constraint. The machine prices and space requirements are as follows. Okay. So let's look at the prices and then the requirement. You have been told that the purchase prices, because remember there's a budget cost. Okay. The purchase prices are 8,000 and 4,000. 8,000 for press, 4,000 for lace. So that budget constraint, if you are to write the budget constraint, how is it going to be? Okay. Remember, press is X1. So you're going to get 8,000 X1 plus 4,000 X2. And we are told it's a budget, so there's a less than or equal to. And you are told that the budget limit is 40,000. So that is 40,000. This is the budget constraint. What about the space constraint? So this is a budget. The space constraint, we are told that we have 15 for the price, so 15x1. And then you have 30 for the lathe, so you have 30x2. Now, how do we know that that's less than or equal to? Well, you told it that, okay, we have 200 square feet available. That's it here. 200 square feet available. So that will be less than, because of the word available, 200. That's the floor space. Now, once you're done with this, you have two more constraints you got to deal with. One is a non-negativity constraint. That is, each of the x's, xi, should be greater or equal to 0, where I is 1 and then 2. That's the first one. And you want to prove that these are integers. So you can simply add and after this, you do a comma and write and integer. And that's it. You can write it int or write it in full. That is it. Once you introduce that and integer, you know that this is an integer programming problem. So this is how you formulate this whole scenario. This is a total analysis. The complete model is this. So let me just show you the complete model. That's it. That's a complete model. All right. Now let's go to another example, unless you have a question, but let's go to another example. The example, by the way, if you can remember, I wrote my x1 and x2 as xi. Xi greater or equal to 0. And xi integer. Okay, so that should tell you that xi is x1 and x2. Let's go to another level of integer programming problem. All of them, the fact that we're calling it integer means that you will have whole numbers. You are supposed to have whole numbers in there. Let's look at this storyline. Legon Council must divide 4 recreational facilities. They have to choose. They have to choose. They have to choose among pool, tennis, athletic field, or gymnasium. And they got to choose that in such a way in order to maximize usage. So if you are building a pool, the pool that you are building, it should get a lot of people coming in there. If you are building a tennis center, the tennis center must have a lot of people, engaged in the tennis. So you must have a lot of people. If it is gymnasium, you must have a lot of people. You want to increase the daily usage. So that's a maximization problem. Now, the expected daily usage, the expected cost, the land requirement is as follows. So you've been given these as Legon Council has 120,000 budget, 12 acres of land. So you have a budget constraint, okay, that you are being told to take into consideration. So you have a budget constraint here. So you expect some element that will create that budget. And then you also have acres of land constraint, okay? So you have land constraint there. What else? Well, there's another clue here. Because swimming pool and tennis center must be built. The word must is important. B is important. It must be built on the same piece of land. Only one of these two can be built. And the council want to know which facility to construct in order to maximize expected daily usage. Now, before we proceed, let's look at the information that we already have regarding these construction. So the first information that we have, okay, on the left here, the first information you have is a recreational facility. What are we building? The people, the total number of people who will use it after we have built it, that is expected number every day. How many people use it? This is the cost of building each one. And then the land, acres of land required to build. Of course, you want to spend less costs and then less acres of land whilst you are increasing the number of people. If you look at this list here, the number of people, okay, is increased in which facility? You can tell me. The number of people are increased under which facility? Under which facility do we have a higher number of people? You can type it there, or you can raise your hand. Okay, so I have an answer from Isaac. Isaac says athletic field. Alberta says athletic field. Mary says athletic field. Gladys, Ya, Kofi, Akosia, Safako, Samuel, Emmanuel, Felicia, Farida, Paakwesi. All of them are indicating athletic field. Okay. So looking at this whole table, why would you say that athletic field, even though it is the one that you may probably have to focus on, might not be the one to focus on? You can tell me why it might not be. What makes it not possible also to not focus on athletic field? Because you used only one criteria to judge athletic field. What could you have rather used? What's his name? Dorothy. Oh, Judith. Let me go to Judith first.
Sir, so from the diagram you showed, the land required to build the athletic field is 7 acres of land. And because we have a limit, you may not be able to have that many built. So when you do build the athletic field, it may restrict the number of the others that you can build.
Okay, so you want the land size to be what? What do you want the land size to be?
So the
land size is 7. What do you want it to be?
So the land size, ideally, the land size should be small.
That's it. And what about the cost?
So the cost of building it is 25,000. Actually, compared to the other facilities like the gymnasium, the cost is relatively affordable.
Okay, so the cost is too high compared to others. Okay. In fact, not others, only one of them compared to one of them.
Yeah.
So it is being penalized in terms of cost and land, even though usage is high. And then the one that is also having the cost, which is cheaper cost of 10, that one too is not increasing the number of people. Okay. In fact, that one has a smaller land size, but the number is very small. In fact, it has the smallest number, tennis center. So clearly, there are several trade-offs, and that is why we got to now optimize this whole thing well. So we need a couple of decision variables. What is going to be our decision variable? What do you guess to be the decision variable? Because having understood what we are dealing with should guide you in knowing what the decision variable is. What do you perceive to be the decision variable? And that comes from the first slide here. The idea comes from the first slide. What should be the decision variable? Okay, I've got some hands raised. Let me go to Emanuela.
Thank you. Please, I think the decision variables will be the construction of either of the recreational facilities. This is because we want to know which of them that has to be constructed. So X1 will be the construction of a swimming pool, X2 the construction of a tennis center, X3 the construction of an athletic field, and then X4 the construction of a gymnasium.
Okay, what other sentence could you have used instead of the construction of the construction?
The building of.
No, I'm not asking of the synonyms. What does that mean? What does that sentence say? Construction of gymnasium. What do you mean? Why?
Okay, so it shows whether that particular facility should.
What you mean? Why are you not saying the number of gymnasium to construct? The number of fitness to construct.
Okay, because we want to, we have to choose which of them to construct. We are not looking at how many gymnasiums to construct or how many athletic fields to construct. We just want to know which of them we have to construct.
We just want to know whether or not we have to construct any.
Yes, please.
Not just each of them, but whether or not.
Whether or not, thank you.
So when we pick each one, we want to know whether we're going to construct that one. When you pick the next one, we want to know whether we're going to construct the next one. All right, so yeah, so whether or not to construct, that's another sentence I'm asking you to say. Whether or not to construct, or whether or not to build gymnasium, whether or not to build tennis, whether or not to build athletic field. That's what I meant by that. Having an understanding, but you've done very well. Having an understanding is very important because that's the same thing I put into the slide, the construction of. So when you tell me, for example, the construction of, I would say probably that you're copying it from the slides, but when you explain it to me, or you use a different way to say it, then I understand. Okay. Yeah, but it goes to show that you understand what you did. All right, so this is the decision variables, okay? Whether or not to construct any one of these. Okay, so now we have some constraints to deal with. First of all, is this an integer programming, or it is, which type of the program? Well, if you look at the heading, it's obvious. Okay. So this is a binary integer programming. Binary integer programming problem. Why? Who can tell me why? Why is this a binary integer programming problem? Why? Why not pure? Why not mixed? Why not pure? And why not mixed? Linda. Why not pure?
Thank you. Thank you, Doug. It's binary because we would like to know if there's a possibility of constructing any of these decision variables.
You didn't end the sentence. If there's a possibility of either constructing
it
or not constructing.
Yes, or not constructing, yes.
Good. That's it. Either constructing or not constructing. That is why it's a binary integer. So how do you represent that? How do you represent that? Well, we've already indicated. So if you are representing that, then it means it has to have a 0 or 1. When it has a value of 1, it means it's being constructed or it's going to be constructed. When it has a value of 0, it means we are not going to construct it. So 1 means construct, 0 means don't construct. And that is what makes it binary. Okay. All right. So what is going to be our objective function then? What is going to be our objective function? How would you have formulated the objective function, given all that we've spoken about? Now I'm showing you the data in front of you. What would be, how would you have indicated the objective function? Is it Z-min or Z-max? And which of these 3 columns are you going to be dealing with? Because those are the ones that have the numbers. Which of them? Is it the people, the cause, the acres? Which one are you doing? Let me ask Beauty.
Oh, sir.
Yeah.
The Z, we are maximizing usage.
Okay.
So we are going to concentrate on the expected usage to form the Z, our objective function.
So what will it be?
So it will be x 300 x1 plus 90 x1 s2 90 x2 plus 400 x3 plus 150 x4.
Okay. Let me ask you something. Don't go away. Let me ask you something. What do you expect x1, x2, Let me just focus on this. What are the likely numbers for X1? What are the likely numbers for X1? Is she gone? Beauty.
No, sir, I'm here.
Yeah, tell me. What are the likely numbers for X1? Is it 4, 5, 10, 20, 30, 100? What are the likely numbers?
The likely numbers of X1.
Yeah. All right, don't worry. Some people have raised their hands, so it means that it can guide you. Let me go to Princess. Princess, what are the likely numbers of X1 and why? Princess, you sound far away. I can't hear you at all.
Sir, please, 1 or 0.
Why?
Because you said let S1 be the construction of swimming pool. You're not looking at the number. So either you construct it or you don't construct it. That's why I said if you construct it, then it's 1. If you don't construct it, then 0.
Perfect. Job done. That's it. So if X1 is 0, it means that we are not constructing it, and so the 300 is irrelevant. If X2 is 1, it means we are constructing it. So the 90, the 90 will be multiplying the 1. So the 90 becomes relevant. So it means that the number of people will be relevant. If the X3 is 1, it means that the 400 number of people are relevant. So it means that we are going to be dealing with all of this. Anyway, so that is the objective function. Okay, that's objective function that you are doing. And the question now is, what are the constraints? What will be the next constraints? Who can tell me the constraint and then how to write the next constraint? You can tell me the constraint and how to write the next constraint. So the constraint here we have is what? Is cost. Okay, cost or the budget. So how do you write a budget constraint? The budget constraint is going to be 300, so 35,000. I want to remove the 1,000. So 35K X1, okay, plus 10K X2 plus 25K X3 plus 90,000 X4. And you have been told that all of these are less than or equal to 120,000. How do I know the 120,000? It was in the question. Okay. The question says, the legal counsel has 120,000 budgets available. And you can see that the acres of land is 212. So what it means is that on this right-hand side, you should have 120,000. So that is the budget constraint. What about the acres of land constraint? Remember, the right-hand side of that is 12. It is 12. Okay. So how would you have written that? Who can raise their hand or who can write the answer there for me? Anyone? How would you have written that? Let me give it to Forsen.
Okay, thank you, sir. We have 4x1 plus 2x2
plus 2x2
plus 7x3
7x3
plus 3x4 less or equal to 120.
Equals to 12.
Hey, sorry, 12. 12. Sorry.
All right, very good. So this is the requirement. Okay. Is there any other thing to do? Well, let's go to the storyline. Okay. In the storyline, you were given some constraints. It says, because swimming pool and tennis must be built. Let me clear the content here. Because swimming pool and tennis must be built on the same land. You can't use both of them. You can't build both of them because the same land will have to be used for tennis and pool. Okay, so only one of these can be built. how will you write that constraint? How will you write that constraint? Only one of these can be built. Well, before you can start writing these things, let me just walk you through a little bit of these English terminologies. Because sometimes when you don't have a clear idea of these English terminologies, it can be very, very confusing. So, so this was a contingency constraint. It says that you can't build both, you got to build only one. Okay. Now, what is the symbol for the word or? And what is the symbol for the word and? You can tell me. Or means what? And end means what? Yes, BT. Or is what? And end is what?
And is plus or the sum. And then or is be equal, less or equal to either this or that. So less or equal to.
Okay. I like the speed in which you are answering the thing. That is quite not the case. That is not the case at all. Or is plus and is times. Or is plus and then end is times.
So thank you.
Note of that. So on the basis of this, we have been told that either swimming pool, which is X1, or tennis, which is X2, can be built, but not both. So first of all, we know that tennis, the swimming pool is X1, and then the or means that it is plus, and tennis is X2. Okay. Now the question now becomes, either of them can be built. What does the can be built mean? Now the word being built means what value? Being built means what value in this context? Very good answer. Okay. I've gotten some answer from Obaya and Dinyako and Princess. Okay, so build means one. Okay, so the question now is, what symbol then is can be built? What symbol is can? Now, if I can do it, if I can do something, it means that I can also not do it. Do you agree with that? So I can do it is equal to, I can also not do it is less than. So if they can be built, then the symbol in question is less than or equal to. So can be built is less or equal to. Because the word one is being built. Anything below one is what? Is zero. Remember, we are dealing with binary. Anything below one is zero. It's not 1.5 because we are not dealing with decimals. So anything below one is zero, and zero means not building. So if I can build, then it means I can also choose not to build, which is zero. That is why it's less or equal to one. But if the thing had been must be built, either swimming pool or tennis must be built, what symbol are we dealing with there? What symbol are we dealing with? Is equal to Solomon. Okay, is equal to. Okay. So in this context, we are dealing with an equal to symbol. And that is a point of interest if it is must be built. Now let me see whether you have an understanding of these. Okay, so let's get to some couple of examples. So the one I just said is called a mutually exclusive constraint, the one I just went through. Okay. And then the must be built, I've also gone through that. That one is forcing you. So that one is multiple choice constraint. Let me ask you this. Okay, let me ask you this. Of course, don't forget your non-negativity constraint and the binary constraint. Please note, this is an integer. You have to still remember that you still have your non-negativity constraint. But the non-negativity constraint, note it. The non-negativity constraint says xi is greater or equal to 0. Now, that word is greater or equal to 0 it can be 0, right? And it can also be 1, because remember this one, the only values we are looking for is 0 and 1. So instead of the non-negativity constraint, you can write the non-negativity constraint all right, and then you can add and binary. Okay. When you add and binary, it means that it's 0 or 1. Or you can just write them just as it is here. You write all of them and say that they are all equal to 0 or 1. Just like that, to indicate that we are dealing with binary. So please note the difference between binary and integer is that integer is broader. Binary is specific aspect of integer. Integer is 0, 1, 2, 3, up to infinity. A binary is just 0 and 1. So 0 or 1. Okay. So this is the non-negativity constraint, and then this binary becomes the integrality constraint. Okay. It becomes a binary integer constraint, if you want to say that. Okay. All right. So now we've been able to get our constraints, okay? And then the implicit, the one I said is already embedded, is the binary constraint. Now let me ask you this. What if these were the constraints that were given instead of the previous one? Suppose you were told that exactly 2 of the constraints must be built. Suppose you were told exactly 2 must be built. Exactly 2 of the 4 projects must be built. How would you write that constraint without copying that understanding? How would you write that constraint? Exactly 2 must be built. Linda. Exactly 2 must be built.
Okay, thank you, Doc. So we have to take notice of the wording, which is the must be built. Then the exactly 2, which is the number, that means the must be is going to be equal to 2. So we have the x1 plus x2 plus x3 plus x4, which are the 4 projects, equal to 2. That's how it's going to be.
Very good. All right. So this is it. This is it. So x1, x2, x3, when you combine them, there must be 2. So let me ask you. So if x1 is 0 and x4 is 1, what is x2? Let me check you here. If x1 is 0 and x4 is 1, what is x2? You can raise your hand and tell me. Francis gave me a correct answer. He says 1, 0 or 1. And that is true. Okay. It's supposed to be 0 or 1. If you said 0, you are wrong. If you said 1, you are wrong. But if you said 0 or 1, perfect. Okay. Why? Because you don't know whether it is 1 or 0, because x3 can take any value. Okay. But if I said that x0, x1 is 0, x1 is 0, x2 is 1, x4 is 1, and x3 is 1, what to be the value of x2? What to be the value of x2 here? It will be 0, exactly. It means you're not going to build it at all. You're not going to build x2 at all. That's what it means. Okay, now let's move on. These ones are cool. It's just to give you, suppose you have no more than 2 projects must be built. No more than 2 projects must be built. How will you write that? No more than 2 of the projects must be built. No more than 2 of the projects must be built. How would you have written that, Emanuela? Emanuela, I muted you and unmuted you, but it came back. Let me try it again.
There's that phrase must be built, which means that we are looking at an equal to. But at the same time, you're also looking at no more than. So it's either we build 2 or less than 2. So I think the sign would be less than or equal to 2.
How will
So
you
now
write
the
it?
presentation will be x1 plus x2 plus x3 plus x4 is less than or equal to 2.
It's less or equal to 2. Very good. Okay. That's it. That's the meaning of no more than. More than is greater than. Okay. Not greater than will be less or equal to 2. And that is how it's supposed to be. Super, super. Okay. Now, what if you had a statement that says if swimming pool is x1 and it is very important and tennis is less important? What does this constraint mean? You have been told in the story that swimming pool is very important, although tennis is less important. How would you write this? How would you write this? This is just to tease your brain. Okay. The relationship is between x1 and x2, but what symbol will come in between them? What symbol will come in between them? All of you who are saying greater than, you are wrong. Okay. Because whatever dictated your mind to write a greater than is what makes it wrong. Whatever dictated your mind to write less or equal to is the right one. So let's watch why. Okay, this one, I don't want to drag this. Okay, let's watch why. Because if something is less important, it doesn't mean it's not important. Okay, so this is a conditional constraint. And this is supposed to be x2 being less than or equal to x1. It's not like x2 is less than x1. No, that would mean that x1 is not important at all. But it says x1 is less important. So there's some kind of importance. And that makes it less than or equal to. Less than or equal to. Okay, let's go to the co-requisite constraint. What if you have this condition? Okay, swimming pool should be built if and only if tennis must be built, and vice versa. Yes, Kofi.
Yes, sir. It was mine is a question. So the point you just made, obviously we are taking a binary decision, that is build or not build, and so if you make the statement of one is less important than the other, does it not then presuppose that if we have to take the decision of build, then it's either a 1 or a 0? So then it obviously means that the second one, in this case, which is tennis, should not be built at all. And so
okay, so first of all, not necessarily. Let me ask, you said that we already know that we are already doing binary, right? What if we don't know? What if we don't know that? What if we don't know? My good friend Kofi, let's discuss quickly before you.
Yes.
What if we don't know? How would you have written?
Yes, sir. So if we don't, it'll be difficult not to know, because your decision is based on whether to build or not. So
my question is that
right from the beginning.
No, I'm not talking about building or not building. I mean, we could still have decided on the number of building. But I'm saying that what if we don't know? But even if we know, like you're saying, what harm will it also cause if it is less than or equal to? Because if it is less than or equal to, you still, and you know that it is 0 or 1, okay? And it is 0 or 1, you can still make it 0. The symbol means that you can still make it 0. The less than part means it can be 0, right?
Yes.
And then the equal to part means that it can also be itself.
Yes.
Yeah. So you have allowed that possibility. because it's not unimportant.
Okay, so I think that my confusion here will be on what basis would someone decide, or would the statement be made that one is more important than the other? Is it not on the basis of it's being built or not, or it will be on another basis in terms of maybe cost or land size or something like that?
Yeah, it will be on the basis of something else, but because that something else is not captured fully here, that is why we have to use the less than or equal to instead of just restricting ourselves to the less than.
Okay, that makes sense.
All right, what if swimming pool should be built if and only if tennis center must be built and vice versa? I think this one is easy. Okay, it says I will only build swimming pool. That is, swimming pool is equal to 1 if and only if tennis is 1. So what is the relationship between swimming pool and tennis? They are the same. That's what I mean. They are the same. I will only build swimming pool if I'm going to build tennis. So it means that the value of swimming pool, I don't know what the value is, but whatever the value is the same as the value of tennis. So this is a symbol of equality. Okay. All right. So this is your final model. This is a complete model. And watch it. Okay. At the bottom, you have the integrality constraint, and then you also have the binary constraint. The binary constraint, sorry, at the end, you have the non-negativity constraint, and then you also have the binary, which is the integrality constraint. So this is it. Let's look at the last one before we go to the real reason why we are here today. The last one is where you have mixed integer, and I'm not going to, stretch this one so much. I'm just going to give you some idea. Okay, I've got some questions. Judith, you have a question, and then we'll go to Kofi. Yeah, Judith.
Yes, sir. So, concerning the non-negativity constraints and then the binary constraints we're combining, I just wanted to find out that is that also going to be constant as far as we know that we are dealing with like binary, like the way you've written it at the bottom, that x1, x2, x3, x4 is greater than or equal to 0 or 1. Is it going to apply for every binary problem?
Yeah, for every binary. For every binary.
Yes.
When each one of them is binary. When each one of them is binary. Because remember, you can also have a situation where some of them are binary, some of them are not. You know that?
Yeah.
When
so in the case, I was going to ask, maybe I'm sure you deal with it later. I'm going to ask that.
I'm going to deal with it later. Whatever you are going to say, I know. I'm going to deal with it.
Okay, all right.
That's the next one. That's a mixed. I'm sure your question will be answered here, right? Yeah. So Nancy has $250,000 to invest in building, land, and bonds. I'm not going to formulate this. I'm just going to ask you to tell me which one is binary, which one is integer, which one is non-negativity. Building, land, bonds. Which one will carry non-negativity constraints? Which one will carry binary constraints? Which one will carry integer constraints? That is pure integer constraints. Yeah, tell me. Which one will carry what? Which one do you think land will carry? Land. Let's start with land, the easiest one. Land will carry what? Which one? Land will carry what? Manuela says building will carry binary. When you say land is mixed, what do you mean by mixed? You have to be specific here. What kind of mix are you talking about? What will land carry? That's my question. What kind of constraint will land have? Land. Okay, so land will have normal non-negativity constraints. Okay, because land can be decimals. So land will have normal non-negativity constraints. Okay, now let's start with bonds. Bonds will carry what? Remember, bonds, you're talking about the paper. Building, let's deal with building. Building will have what? What kind of constraint? Pure. You can't have 2.5 buildings. You cannot have 2.78 buildings. So land will have pure integer. 1, 2, 3, 4. Okay, just like bonds. Okay, just like bonds. So this is it. Look at the bottom here. So at the bottom, you will notice here that you have the non-negativity constraints, okay, for land. So that one is just non-negativity. But when it comes to the building and the bonds, you don't just have non-negativity, but you also have and integer to indicate that we are dealing with integrality, pure integer constraint for these two. So these two must be whole numbers. That's all we mean. They must be whole number. There is no binary here. There is no binary here in this category. We have normal, pure integer or integer constraint. All right, any question? Yeah, Emmanuel, you're right, pure integer. Emanuela, that is also pure integer. That is pure integer. Okay, so ladies and gentlemen, that is the general. Now let's get to the real reason why we are here today. We are going to look at an aspect of integer programming, which is known as the fixed charge. The fixed charge. I will encourage you to have your notes with you and be writing it along what I'm about to do. Okay, the fixed charge. This is a linear programming that we are going to do, and we're going to do it in such a way that the most important thing is learning how to formulate it, not solving it. Solving it, the software can do it. And that particular exam condition, you also need to simply learn how to formulate it than solving it. The software will do the solving for you, but you got to learn how to formulate it. We have the fixed charge and employee scheduling, okay? And this one, I have the note, I'll give the two to you, okay, so that you can learn these two yourself. But I'm going to focus on the fixed charge. So let me just start by reminding you of something. Now, do you remember microeconomics? In the microeconomics, when we are talking about cost curves, okay, the y-axis will normally have the cost, and then the left x-axis will normally have the quantity. But the quantity is what we call in our story here today, x, x1, x2, x3, okay, the quantity. So if you are producing, okay, there are two kinds of costs you can incur. The first cost is called a fixed cost. It is normally horizontal. The fixed cost is that kind of a cost which is independent of the level of production. What do I mean? Look at the x-axis here. If I were to produce at this x-axis, okay, if I were to produce at this x-axis, and I produce 10, that cost, that fixed cost, let's say this fixed cost is 50. If I produce 10, according to the horizontal FC axis, I will incur the fixed cost of 50. If I produce 20, I will incur the same fixed cost of 50. If I produce 30, I will incur the same fixed cost of 50. If I produce 100, I will incur the same fixed cost. Why? Because that cost is independent on the level of production. That cost is already borne. And I'll give you practical examples very soon. The cost is already incurred, is already borne. I'll say what, Linda, you have a question? And then I'll go to Joanna.
Doc, please, when you started defining the fixed cost, the line was breaking, so I couldn't hear anything at all.
No problem. I've repeated it twice. I said that fixed cost is a cost that is independent of the level of production. Is independent of the level of production. Okay. So the cost is already borne. That's what I mean. Okay, let me give you two examples. Example number one. If you are going to build a business school and teach, okay, and then you use 2 years to do the building, but the third year you employed nobody, and you did not admit any student, the cost of production is already borne. You have already incurred the cost of the building. That cost is still run, it's gone into your life. It's borne, and therefore it's a fixed cost. Another one is rent. Suppose you go and actually pay a deposit of 2-year deposit to rent a house. If you rent that house and you tell the landlord, I want to rent your house, but I do not want to pay. I'll come and pay in 2 years' time. The landlord will not give you the house. Now, but if you pay and you still don't live in the house, the landlord doesn't care. That cost is already incurred. So that fixed cost is that kind of a cost which is already incurred. Whether you produce or you don't produce, that cost is already gone. That's fixed cost. And that's what we call here fixed charge. Fixed charge. Now, in normal economics, you know that there's another kind of cost which depends on the level of production. Normally, that one starts from the origin. So that one, the cost starts rising only when you start producing. Okay? And that cost is called variable cost. Variable cost is variable. It means that it's changing. Even if you look at the curve, as you are producing 10, the cost is, say, 10. As you are producing 20, the cost goes to 40. As you are producing 30, the cost goes to 60. So that cost is increasing with the level of production. Okay, that is variable cost. The variable cost plus the fixed cost, or let me write it better, nicer. The fixed cost or the fixed charge plus the variable cost is what will give you the total cost of the firm. So the total cost of the firm is the combination of the fixed cost and the variable cost. How do you find profit? If you have your total cost, how do you find profit? Who can tell me? Who can tell me? If you have your total cost, how do you find your profit? Who can tell me? This is basic accounting or basic entrepreneurship. If you have your total cost, how do you find your profit? Beauty.
Profit, you can find it by taking the total cost from total revenue.
Perfect. Excellent. So your profit is given by your total revenue minus your total cost. But remember that this total cost is made up of two things in it. One is the fixed cost. So you got to take out the fixed cost. And the other is the variable cost. So you have to take out the variable cost. What is total revenue? You can tell me. Let's go back to the total revenue. How do you calculate total revenue? What is total revenue? I'm just borrowing some economics principles from you. What is total revenue, Abbas?
Total revenue is price.
Yes.
Price.
Yes, total revenue is price times quantity. So if I know my price and I know my quantity, I can find my revenue. If I know my total cost, and I can only know my total cost if I multiply the price by something related to the cost. Okay, so the price times the cost will give you the variable cost, and then the fixed cost, which is K, will be added to it. And I'll take all of these total costs from the revenue and that will give me my profit. Let's bring this principle into our fixed charge. And the best way to explain this fixed charge is taking a real life example. Okay. Now, let's take this. Textiles Limited manufactures 3 types of clothing. Please pay attention here. Whatever you are doing, stop. Stop for once and pay attention to what I'm about to share with you, because this is critical. Slight, obstruction, slight disturbance or interruption will not make you focus. Textiles Limited produces shirt, pants, and shorts. In manufacturing each type of this clothing, the company has to have suitable type of machinery available. That word is an important word. You need a suitable type of machinery available. What it means is that if I want to produce a shirt, I need shirt machinery there. If I want to produce shorts, I need shorts machinery there. If I want to produce pants, I need pants machinery to be there to produce the pants. Now here's the point. The machinery needed to buy to produce each type of clothing must be rented at the following rate. So I cannot produce a shirt machinery unless I have rented the shirt. Sorry, I cannot produce shirts unless I have rented a shirt machinery at 200 cedis. The same way I cannot produce shorts unless I rent short machinery for 150. The same way I cannot produce pants unless I've gone to rent the pants machinery at 100 a week. Are you beginning to identify the fixed charge? Are you beginning to identify the fixed charge? Okay. Now let's move on. Let's move on. Follow me here. Manufacturing each type of requires an amount of cloth. So you cannot produce shirts, shorts, pants, unless you get the amount of cloth and amount of labor. These are the resources needed. And these resources are shown below in this table. So if you look carefully at the table, it guides your mental frame to know what we are dealing with here. First of all, you are producing these things. You are going to get revenue from them. But your revenue is obtained from the price, the sales price. Okay. So I need to get my revenue from the sales price. Now, revenue is price times quantity. And so we know the prices here. As for the quantity, we don't know now. Okay, we don't know that. They are X. But to produce this shirt, this shorts, this pants, you need to incur some variable costs. So you incur 6 variable costs for shirt production, 4 variable costs for short production, 8 variable costs on pant production. Now, why did I put them here on this right side, but I did not put them here on the left side? Because they are variable, just as the prices are variable. The prices are increasing and falling. That's what I mean by variable. And then the variable cost is increasing and falling, is changing with the level of production. That is why they are there. Now let's go to the left part of the table. I will need a certain material to produce the short, and I will also need a certain labor time to produce it. So if I want to produce shirt, I need 3 hours of labor time and 4 yards of cloth. If I want to produce pants, I need 6 hours of labor time and 4 yards of cloth. Okay, now let's go to what we are required to do. We are told that, we are told here, each week, 150 hours of labor and 160 square yards of cloth are available. The word available means what? It means that these items must be on the right-hand side of the constraint. And it also means that these 150 and then 160 for labor and cloth are all carrying the symbol of less than or equal to because of the word available. We are told to formulate an integer programming problem that will maximize the profit of Turner Textile Limited. First thing you got to do is to formulate the decision variables. Write your decision variables, and then after that, you write your constraints. So, what are we deciding on? What is our decision variables? Who can tell me? What is the decision variable? What is our decision variable? What are our decision variables? Somebody has documented that. Huh? Yes, what is our decision variable? What should the company decide on? That's deep, eh? The company is supposed to decide. Okay, you got Judith. Yeah, Judith, tell me something.
They have to decide on the shorts, shirts, and then pants numbers to produce. Okay,
I like the word numbers that you brought in the end, because I thought you were going to start with the number of shirts, shorts, and pants, but that's the same thing. Okay. So we've got to decide on the number of shirts, shorts, and pants. So we will represent X1 by the number of shirts to produce. Okay, so take note. The number of shirts to produce. Now, I could ask you this question, and you know the answer too already, that these items, are they, and this is important, are they integers or they are not integers? You can tell me. Of course, you got to give me a reason. Are they integers or not integers? Okay, some of you are giving right answers there. Okay, Francis, they are integers, yes. So they are integers, and they are pure integers. They are integers and they are pure. You cannot have 1.5 shirts. Okay. So X1, that's what we are dealing with, number of. But because they are integers, you got to really incorporate that in your language. You got to incorporate that in your language. You don't have to just say it. I got to incorporate that when you get to the what? To the non-negativity constraint. Then after that, you add the integrality constraint. You write the non-negativity constraint, then you write the integrality constraint. So don't forget that. That will indicate that you understand that they are integers. Okay. So this is how all your decision variables will have to be. But there's something also you got to work on. Okay. We are told that the cost of renting a machinery depends only on the type of clothes. It doesn't depend on the amount of each clothing. This is very important. This is where sometimes it can be abstract in your head. Go back to the sentence, it'll give you a better understanding. It says that the manufacture of each type of clothing, that's what it says. The manufacture of each type of clothing requires that the company has the suitable type of machinery. What does that mean? What it means is that you cannot produce the X1. X1 is for shirts. You cannot produce the X2 shorts. You cannot produce the X3. It doesn't matter which number, how many numbers. You can produce as many numbers as possible, but you cannot produce it unless you have the short machinery there. Unless you have the short machinery there. Unless you have the pant machinery there. If they are not there, what machinery are you going to use to produce? So those machinery will have to be there. But those machinery are different from the product you are producing, the shirt you are producing. It's simply called a shirt machinery. It's not a shirt. It's a shirt machinery. So it means that another of your decision variable you got to decide on is whether you want that shirt machinery or you don't want that shirt machinery. You got to decide on that. As for the shirts, shorts, and pants, you've already decided on that you're going to produce. But the next decision on them was how many you want to produce. That's why that one is dealing with number. But with the machinery, you got to decide whether you want it. Why? Why? Because if you don't decide whether you want a pant machinery, you're not going to produce pants. I don't want any pant machinery. All right. Then you cannot even produce any number of quantity of pants that you intended to. You need to decide on whether or not you want a shirt machinery. And therefore, those items will have to be decided on. But their decisions are just two-way decisions. You simply decide not having the number of shirt machinery. No, it's not about that. It's deciding whether you want shirt machinery or you don't want it. And so that makes them binary. So for each shirt machinery, for each shirt, you need a shirt machinery, Y1. But the Y1 is a variable that you either want it or you don't want it. So this is binary, which is equal to 1 if you want it. Okay, if you want it, that is, I'll put here if I'm going to produce X1. If I'm going to produce X1. And then 0 if I am not going to produce X1. So that is if X1 is 0. Because if X1 is 0, why do I need X1 machinery? If shirt is 0, if I'm not going to produce shirt, I don't need any machinery for shirt. But if I'm going to produce shirt, then I need the shirt machinery. So the Y1, which is the machinery, is a categorical binary variable. It is another thing to decide on. And the same thing goes with the others. Okay? That's it. If you have a question on this, let me know, okay, so that I can explain further. Other than that, I want to assume that you get it. So Y1 is 1 if I produce shirt. Otherwise, is 0. Yes, Solomon.
So in a situation where the question states that there's maybe a quantity of shirts that each machine could make, would that make the Y1, Y2, Y3 non-binary?
No, because whatever machinery that you are talking about, did you say the quantity of machinery that it has to make? Is that what you said?
The number of shirts that each machine could make, the capacity of each machine.
Even if you tell me the number of shirts that, shirt machinery can make, the shirt machinery is still binary. You see, that machinery That machinery is needed to produce as many shirts as possible, isn't it? That's it.
Yes. Okay.
It
yes.
It doesn't matter whether you're producing 200 shirts or 2 million shirts. The machinery must be there. The machine must be there. And that is what makes it binary. That's what makes it categorically binary. And so that shirt machinery is Y1, the short machinery is Y2, and then the pant machinery is Y3. And each one of them can be 0 or 1. So it means that from the onset, we know the values of Y1 and Y2 and Y3 already ahead of time. It is fixed. It is fixed charge. It's either going to be 0 or 1. And please note, when I say 0 or 1, I don't mean that 0 or 1 is presence or absence. Presence is 1. 0, absence is 0. So it's either that thing is there or it's not there. So I already know the answer. What do I mean by I already know the answer? What I mean is that I know the answer because even though the question gave us the cost of renting, I will only incur that cost if I am actually going to decide that I'm going to rent that thing. So if you tell me that, you can't tell me as a landlord. You saw me on the road, you say that you are going to pay, $2,000 a month on the house. No. The landlord can only tell me that if I have come to him and I've already told him that I want to rent that house. That is when he will tell me that. But if I've not told you that I'm going to rent that house, you can't tell me the amount. So the amount is, the cost is already born. So the Y1, the Y2, the Y3, these are fixed charges. The charge on them is fixed, is incurred. It's a matter of deciding whether you want it or you don't want it. All right. So on the basis of that, we need to formulate the objective function. But before we do that, understand some few things here. This is important. I've already said it, but I want to repeat it mathematically. So this repetition is only mathematical. If Xj is positive, remember Xj is the item you are producing in quantities, whether it's a short, shirt, or pants. So if Xj is positive, what it means is that if I'm producing shirts, okay, if I'm going to produce shirts, then Yj must be there. That's what it's saying. And I said that some few minutes ago. Yj must be there. So if Yj is 1, if I'm incurring a shirt machinery, if I am actually getting a shirt machinery, that is the 1, then I will use it to produce. Then Xj must be positive. It won't be 0. It will be positive. It will be positive. The same way, if I am not going to produce S shirts, then why do I even have to actually go and buy the machine? So what you are saying is that you can't buy the machine without producing. And you can't produce without the machine. But in terms of after you've incurred the machine, regarding that one, after you've incurred the machine, you can produce, but you can produce as many as you can. But whilst you are producing, you have incurred the machinery cost too. So that one is a one time, but then it's one time, that is a Y equal to 1. But then when it comes to the X, it's positive, it's multiple times. So take note of that. Okay. And on the basis of that, we can now formulate our profit function, and then we can write our objective function. Yes, normally I delay like this because I want some of you to ask questions. So Rebecca, ask your question.
Doc, please, I'm begging you, please kindly explain that place again there. If Xj is greater than 0,
All right, okay. So because it's normally mathematical, if you don't take it, you don't get it. So what it means that if I produce shirts, if I produce shirts in many quantities, in any quantity, okay, if I produce shirt in any quantity, I can't produce that shirt without having gotten the machinery for producing the shirt. So the shirt machinery, I'm just trying to write it in English, the shirt machinery will have to be there. That is what I mean by equal to 1. The shirt machinery will have to be there. That is the equal to 1. But if I don't produce shirts, if I don't produce shirts, what it means is that shirt is 0. Okay. So if I don't produce shirts, and by the way, the J is, I'm using shirts to represent the J. I could use panties, I could use shorts, I could use pants. So if I don't produce the shirts, then there's no way I will incur a machinery, because if I don't produce the shirt, I won't buy, I want to rent shirt machinery. I want to rent shirt machinery. And the fact that I want to rent shirt machinery makes the Y 0. That is what this point is saying. Okay, so if you understand this, this is a crux of the matter. This is a crux that we are actually reading. Rebecca, do you get the picture? This is the deal.
Thank you.
All right. It's good to get these things because we are going to build on them. So on the basis of this, let's write our objective function. Our objective function we know is going to be Z max. And Z max is usually the entire revenue, because Z max is profit in this context. And profit is the revenue minus the cost. And the revenue is a price times the quantity. What is a price? And what is a quantity? Well, we know the quantities are X1, X2, and X3. So the prices on them are the unit prices that were given in the table. So let's go back to the table. And in this table, you will see that on this column here, okay, on this section here, you will have the prices. They are there. So if I were to write my Z max, I write Z max equal to the coefficient times the unit, and the units are X1, X2, X3. And each one has got a number. So the X1 is 12, the X2 is 8, and then the X3 is 15. So it's going to be 12X1 plus 8X2 plus 15X3. So that is total revenue. And the 12X1 becomes the revenue for the X1. Okay, so this is the revenue for the X1. The 8X2 is the revenue for the X2. That is a short. And then the 15X3 is the revenue for the pants. Now, after this, you need to now subtract the cost. And what is the cost? Okay, this cost is going to be total cost. So let me make it minus total cost. But the total cost is made up of two things. The first is the fixed cost, and the second is the variable cost. What was the fixed cost? Well, the question gave us the fixed cost. We are told that each week go up. We are told that the shirt machinery, which is a fixed cost, is 200, short machinery is 150, and pant is 100. So how will you incorporate that? You cannot just write 200, 150, and then 100. No, you can't. Why? Because you have to incorporate the fact that you are going to rent it. Because if you are not going to rent it, if the Y is not going to be 1 for the thing, then the 200, the 150, and the 100 are not necessary. They are not there. They are not necessary. So you can tell me that, oh, yeah, I'm going to get 200. I'm going to get, okay, I'm going to get 200. I'm going to get 150. I'm going to get 100. But you will only incur that machinery cost if you're going to rent the machinery. So you have to attach the machinery item, whether or not you're going to rent there. How do you do that? So just on the fixed cost is going to be, of course, remember, it's still in the bracket. It's going to be the 200 Y1. You attach the Y1. And we know that Y1 is either going to be there or is not there. We know that the Y1 is either going to be 1 or 0. Now watch this, watch this. If the Y1 is 1, then the 200 becomes 200, isn't it? It becomes 200 times 1. Now we know the cost. But if the Y1 is 0, then it will be 0 times 200. So we are left with nothing. And so that means that that fixed cost was not incurred. And that is the point you're talking about. So you have 200 minus 150 Y2 minus 100 Y3. If you don't get this, you let me know. So that's the fixed cost. And please remember in your mind what a Y1, Y2, Y3 mean. They all mean just two possible values, 1 and 0. 1 and 0, that's it. Okay, 1 and 0. All right, Judith, you have a question. And then Joanna will follow.
Yes, sir. I just wanted to confirm why we were subtracting the 150 and the 100. Are we assuming that at the end of the day, we are going to produce just one item?
Oh, these are costs. These are costs.
Why are we going to be totaling them instead by subtracting the 150 and then the 100 Y? As in the 150 Y.
Sorry, you're right. You have to add them together. Later, we're going to apply the minus here for all of them.
Okay.
All right. Joanna, you had a hand.
Yes, I had the same question.
All right, okay. Yeah.
Why we were subtracting. Thank
you. This is typo. It's supposed to be plus in the bracket, then you expand it, and then you attach the minus. Okay, let's go to the variable cost. The variable cost, as you can see, they are on this far right. And variable cost means that it is something, a number times the x's. It is variable, it's changing. Okay. So they will not use the y's, they will use the x's, the quantities that are changing. And they are variable, they change with the level of production. So the variable costs are 6, and you attach that. So let me also keep that one in the bracket. So it becomes 6x1 plus 4x2, okay, plus 8x3. So that is it. So at this stage, we are going to now put them into this bracket and expand them, applying the negatives to all of them. Please, when you do that, you will see that there are some like terms. For example, this 12x1 will be minus 6x1 here. And then the 8x2 will minus the 4x2 here. Then the 15x3 will minus the 8x3 there. So our final Z max is going to be 12 minus 6. That will give you 6x1 plus 8 minus 4. That will give you 4x2 plus 15 minus 8. That will give you 7x3. Then minus, remember I've taken care of the variable cost. So I need to go back to the y's. Okay, so you have minus 200y1 minus 150y2 minus 100y3. This is your final objective function. Now, please note that you're not going to be solving this by hand. Okay, so you don't have to worry about how are you going to solve this and all of that. It's easy. Easy. Solver can do this for you easily. Once you've written the objective function, you can now go ahead and write your constraint. What are the constraints? The first constraint is the labor constraint. The second constraint is a cloth constraint. So let's get that running. Labor constraint and then the cloth constraint. How do we do that? By the way, all the things that I wrote, these are them. So you can see all of them right here. Now, the labor constraint, there's something about the labor constraint. If you look at it, we have been told that we have 3, 2, and then X. What are we going to multiply them with? That's my question to you. Are we multiplying the 3, the 2, the 6 by the Y's, or we are multiplying them by the X's? You can tell. And why? You can tell me, and why? What are we multiplying these labor and cloth with? Are they being multiplied by the X's, or they are being multiplied by the Y's? The X's or the Y's? The X's or the Y's? Okay, I'm getting most answers to, yeah, Beauty. I'm getting the answers to the X's.
Yeah, we'll multiply with the X's to determine the the X. We'll multiply with the X.
Very good, very good. So write the labor constraint. Who can walk me through? Let me write it. This is easy. Okay. So if I were to write the labor constraint would be 3x1 plus 2x2 plus 6x3 less than or equal to the labor limit that you were given. What was the value? I think 150 or so. Let me go and check. Somebody has typed the answer. 150, yeah. And the other one I think was 160. Okay, good. So it shows that you are following. So it's supposed to be 150. And then the cloth is 4x1 plus 3x2 plus 4x3 less or equal to 160. So now you have your constraints all done. Okay. I'm sure you all get a picture here. Now that you've formulated your constraints, and I want to show you the actual values, the actual answer. These are the constraints. You have to now bring your non-negativity constraint. What is the non-negativity constraint? And then you have to also bring your integrality constraint. Who can tell me how to write each one of these? Or both of these? How will you write them? The non-negativity and then the integrality. How will you write them? I'll write them there for me to see. Somebody has written them. Let me see. Okay, Forsen, you've written the non-negativity constraint. You've not written the integrality constraint. So you're fine with the non-negativity, but you've not done with the integrality constraint. What is the integrality constraint? See, this is where if you don't take care, you might forget the integrality constraint. The rest of you, you are not typing. It's only few, it's only, for now, it's only Forsen who's actually documented the answer. The rest of you, I hope you are following. So this is your objective and these are your constraints. Remember, you need the binary constraints for the machinery. So the x's are non-negative and integer, but you also need your binary. And then that will sort out this formulation. But there is a problem or there's not a problem. Let me ask you this. Oh, by the way, in an integer linear programming, for example, under certain exam condition, I'm just going to ask you to formulate. That's all. That's all, just formulate. And then you have your 25 over 25. But remember, the formulation is not as simple as we have just done. Because if you were to formulate it like this, which we have done, which is basically all the information we have, and you were to solve it, this formulation will be wrong. So the question becomes, if it will be wrong, why did you do it? Well, not that it will be wrong as in wrong. It will be wrong because it's not complete. It's not complete. Who has a mathematical eye to recognize that it's not complete? This, you can get the reason why it's not complete right here. The solution is looking at you. Who can tell me, why do I say it's not complete? Who can guess? Okay, I want you to look at objective function. How many unknown variables do we have there? How many unknown variables do we have there? Six. Very good. Now, if you put all the constraints together, okay, forget about the non-negativity and integrality. If you put all the constraints together, how many unknown variables should we, how many unknown variables are there? If you look at the combined constraints, how many unknown variables? Remember, I told you that don't include the non-negativity and integrality. 3. So there's a problem here. Please note the number of variables in the objective function should always be equal to the number of variables in the combined constraints. Even in normal linear programming, that's how it's supposed to be. Sometimes some of the constraints will have only 2 variables. Okay, sometimes some of the constraints will have only 2 variables. But another constraint should also have another variable. So there must be a variable for all the constraints. There must be inside all the combined constraints, there must be all the variables, all the decision variables. So there is a problem here. And the problem is that the constraint does not have the y's in them. The constraint does not have the y's in them. And that does not make, in fact, if you have to solve this model, let me just show you something. If you have to go and solve this model, this will be your solution. Who can tell me why this solution is wrong? By the way, I did this in Excel, and this was my solution. Who can tell me why this solution you are seeing here, this blue solution, why is it wrong? Okay, I got someone raise a hand. Yes, BT.
Sir, please, it is wrong because when you look at the blue one, it means that Y is not used. No machine is used. But when you look at the X1 and X3, it means we have produced X1 and X3. So definitely we have to use the machine. So for Y1, Y2, Y3 to be 0 means that there is a problem here.
Fantastic. That's it. She knows her stuff. If you don't know your stuff, she knows her stuff. So you're telling me that we are producing X1, that is a shed. The number of sheds we are producing is 30, which means that we must have already incurred a shed machinery cost to be producing the X1 to be 30. We must have incurred Y1 to be positive value. But when you come here, Y1 is 0. So if Y1 is 0, why are we producing X1? That's the point she says. So it means that and that is exhibiting the incomplete nature of the model that we had originally here. So what should we do? We have to bring in the y's into the constraint. But that is not rocket science. That is not just bringing the Y, so you just bring in the Y. You got to do some trick. And this is a trick you got to learn and memorize if you have to. This is a trick. The trick is that, and before you can apply the trick, you got to understand that anytime we are producing a shirt or short or pants, we must have a positive or Y equals to 1. We must incur a machinery for that. That's the mathematics. Anytime X's are positive, Y must be equal to 1. So that's the first point. So how can we do that? How can we ensure that that relationship between X and Y is maintained, is enforced? To do that, please pay attention here. To do that, you need a certain rule. And this rule is a rule that is called linking constraint. It's a rule that links the X and the Y. So guys, watch something here. This is beautiful and it's interesting, but it's also technical. If I have my X here, whichever X it is, Xi, or let me put it X, yeah, Xi. And then I have my Y here, Yi. Now watch. There must be a relationship between X and the Y. According to the rule, the relationship must be in such a way that whenever the Y is 1, the X must be positive. Watch. Watch. Follow me. Watch me. Follow me here. Follow me here. Don't turn around. Don't look anywhere. Don't pick up your phone. Just listen. If Y is 0, what should be the value of X? Who can tell me? Because I want to bring a sign between the X and the Y here. If Y is 0, what should be the value of X? It's 0. It's 0. That's it. Okay, Kofi, you started it nicely. So X will be 0. Okay, so that one, we can take care of that. If Y is 1, because Y can only take a value of 0 or 1. If Y is 1, X will be what? If Y is 1, X will be what? No, X cannot be 1. X will be positive. If Y is 1, X will be positive. Unless the relationship we put between X and Y to be equal to, then you can tell me that is that. So what should be the rule? We can put equal to, but equal to is not enough. We have to put less than or equal to. Why? Well, we know that you have to put less than or equal to, but that does not suffice. We need a condition. If Y is 1, forget about the 0, 1. If Y is 1 and Xi, because if you look at this less than or equal to, if Y is 1 and X is less than Y, then it means, and then of course we are ensuring non-negativity, then it means that X is what value? If Y is 1 here, it means X is what value? You can tell me. Remember, we are ensuring non-negativity and we are also ensuring integrality. Excellent, Francis, you got the right answer. Y is 0, it's not 1. Okay, Y will be 0. If this value is 1, okay, Y will be, sorry, if Y is 1, X will be 0 or 1. But the thing is that we don't want X to be just be 0 or 1. We want X to be 0 or positive. So we need something, and that something is given by mi. Don't worry, I'm going to explain mi right now. Mi in front of the y. What is mi? What condition will ensure that whenever you are incurring a machinery cost, at any time you are incurring that machinery cost, then you are going to produce a higher number. M is that higher number. Mi is M1, M2, or M3, depending on how many x's there are. So M is that higher number. M is the upper bound for x. M is the highest value that x can take. Remember that x can take 0, 1, 2, 3, 4, 100,000, 2,000. X can take as many values, but the highest value in the story you are considering, in the problem you are considering, the highest value that x can take is this m. And that is what can link the relationship between x and y. What is m? If I'm going to write the specific equation, the m1 is the highest value for shed produced. M1 with the highest value so you can produce shed of 2, you can produce shed of 10, you can produce shed of 20, but the highest value of shed you can produce is the M1. How do you get the M1? How do you get that M1? There is a way you can get the M1. Remember, the M1 here is a constraint. I mean, sorry, the relationship between S and then the Y with the M is a constraint. So to get that M1 for each, the M1, the M2, the M3, to get that upper bound for the X, to get any of the M1s, M2 or M3, to get MI, let me put it MI. To get any of the MI, you need to solve the constraint in such a way that you can find it. How do you do that? Let's go to the constraint. Okay, please follow me here. This is the best time you want to follow me, okay? So let's look at this constraint. The first constraint is 3x1, 2x2, 6x3, less than. Now I'm going to make it equal to. Because once you make it equal to, you get to know the upper bound. But once you make it less than, then it's like the upper bound, you know, and then some numbers below the upper bound. Okay, so you're going to make it equal to. So let me rewrite this. So I'm now going to look for M1. And please note, M1 is the highest value that X1 can take. All right. How do you get that? Well, what you have to do is that, and watch this, you have to assume in all the constraints, assume that X2 and X3 are both 0. Assume that the X2 and X3 are both 0 in all the constraints. I mean, in this case, the constraints are 2. So in all the 2 constraints. And then solve for X1. Because remember, we said that M1 is the highest value that X1 can take. So I'm going to assume that X2 is 0, X3 is 0 in the first constraint here. And then solve for X1. Then I will assume that X2 and X3 are both 0 also in the second constraint. And then solve for X1. Let's do that. So when we are writing, we will write 3, I'm talking about the first constraint. You write 3x1 plus 2x0. I'm an x2, but x2 is supposed to be 0. So it will be 2 times 0 plus 6 times 0. And then you now make it equal to 150. I hope you are with me. So what is the value of x1 here? Since x2 and x3 are 0, what is the value of x1? 150 divided by 3 is what? Good answers. Okay. So now we know that the value of x1 in this first constraint is 50. All right, put that down. Let's go to the second constraint. In the second constraint, if x2 is 0 and x3 is 0, okay, what will be the value of x1? You will have x1 equal to 160, which means that x1 is equal to what? Make sure you are working some. Okay, all right, it's 40. The question is, you now have two values of x1. One of them is 50, one of them is 40. Which one should you take? I'm going to give you a rule, but you should also find out why am I giving you that rule. You should always take the smaller value. Whenever you are looking for this M1 and you get two values or three values or four values, always select the smaller value. And so between the 50 and the 40, the M1 will be the 40. If you don't ask me questions, I can't talk. So it's when you ask me questions, then I can talk. Okay, so M1 will be 40. Yes, Judith, you have a question. And when I'm answering, you don't hang up so that I know you have understood. Yeah.
Yes, please. So the first constraint we had was called the labor constraints, and then we had the cloth constraint. So I want to find out the constraints with the M1 and the Y1. What's the name of that constraint?
The linking constraint.
Okay.
There are three of them. I'm finding the M1. You see, what I'm trying to do is I'm finding the M1 first, then I'll give you the constraint properly. All right. So guys, why do we take the 40? We take the 40, the lowest value, because, oh, somebody has raised their hand. Judith, is your hand still up? Yeah, Nyako.
No, what I was about to ask, you are explaining.
All right, okay. I thought somebody was going to tell me. Since you didn't ask me, why are we taking the 40 and not the 50? Because remember, we said M1 is the highest value X1 can take. So if M1 is the highest value X1 can take, why didn't we rather take the highest value, which is 50? But we are taking the smallest value, which is rather 40. Well, the best way to answer that is that because the 40, the smaller value will always satisfy the two constraints than the higher one. Let's prove that. Take the first one, the 50, and drop it into the values. Okay, and see whether it will satisfy the labor constraint. If you drop 50, assuming that x2 is 0 and x3 is 0, okay, assuming this x2 is 0 and this x3 is 0, and then you drop 150 under the, sorry, you drop 50 here, you will have 3 times 50, and 3 times 50 is what? 150. So that will satisfy this 150 here. Is equal to, perfect. But let's drop it into the second constraint because it must satisfy both constraints. If you put that 50 here, assuming the others are 0, you will get 150. Is it? Oh, sorry. I'll put it at 2. If you put it here, okay, you get 4 times 50, which is 200. And 200 does not satisfy the constraint because 200 is more than 160. So the constraint is violated. Okay, but let's take the 40. If you drop the 40 here, Okay. If you take the 40 and drop the 40 for the first constraint, you get 3 times 40, which is 120. 120 is still below 150, so it satisfies the constraint. Now drop the 40 in the second constraint. That will give you 160. 160 is exactly equal to the 160 here. And so it satisfies the constraint. So because the 40 satisfies both constraints, that is why we select that. And that is the rule. The smaller value, the smallest value always satisfies all the constraints. Therefore, our linking constraint for the first one, which was, remember I told you it was xi, in this case, x1 less than or equal to m1, y1. Now, if we are to properly write it, we'll write it as x1 less or equal to 40 and then y1. So this becomes the final constraint that must be added. Now you need to do the same thing for the x2 to get the m2, and then for the x3 to get the m3. Are you ready? All right. Let's do that. Let's do that, because the thing is that that's why we are here. We are here for this purpose. This is the main reason. So we are going to calculate. We are going to calculate this constraint now. We are now looking for x2 less or equal to m2 y2, and we are looking for the m2. Now, because we are looking for the m2, which values should we assume they are zeros in the two constraints? Because we are looking for the m2, which values should we assume are zero? X1 and X3, perfect. Good, X1 and X3, you guys are following. So let's assume that this X1 and X3 here are zero, or the other ones. So we'll be left with 2x2 equal to 150, which means that x2 will be what? 75. We go to the second constraint. The second constraint, if x1 and x3 are zero, we'll be left with 3x2 equal to 160, which means that x2 is what value? I want to get that answer to be sure. Correct 2 decimal places. Make sure you are working some, it will help you. 53.33, very good answer. Okay. 53.33. Even though, partly because we are dealing with non-negativity constraint, and also because we are dealing with whole numbers, normally it makes sense to round it to the nearest whole number. So if you were to round it to the nearest whole number, it becomes 53. Okay, therefore, our final value for M2 will be what? What will be our final value for M2? Final value. It will be 53, excellent. Okay. Therefore, if we are to rewrite our equation, we are going to rewrite our equation to be x2 less or equal to 53 y2. This is how our linking constraint is going to be. We have to find the third one, and after that, we'll put all together and write the final complete model. Let's do for x3. So we've done for M1, we've done for M2. Let's go and do for M3. Now that one, I want you to do it for me. And when you are done, privately send me your answer here. I want you to do that last one for me. When you are done, privately send me your answer. Send me your answer here, not anywhere. If you can't send it here. Okay, Emanuela, you've given me your final answer. I like it. It shows that you've done. Dorothy, you give me Dorothy. I like your answer than Emanuela's answer because I needed the two answers you had before you tell me the one you chose. Emmanuel, I don't like your answer because telling me the one you chose is not enough. I need you to say that the two answers. Dorothy did that. The two answers, and then you say that M3 is this. Give me the two possible answers before you tell me what the M3. That one I know you worked it. Samuel, your answer is correct. You got a perfect answer. You gave me the two options before you gave me the final. Mohammed, good answer. Good answer, Mohammed. If you are here, I will implore you to be doing what we are doing, okay? Kwesi, you got a perfect answer. Sefako, you're not giving me the right answer. Samuel, you have not given me the right answer. You've just given me the two answers, that's okay, but you've not selected which is the right M3. The same thing Princess has done. You've not selected which is the right M3. Isaac, correct answer. Joanna, correct answer. Judith, best answer. Very good. So excellent, that's it. So this is it, okay? Once you do all of that, now we can now conclude that our X3 is less than or equal to 25 Y3. That is how the constraint will be, okay? And so we are going to add the other two. The other two were X2 less or equal to 53 Y2. And then the first one was X1 less or equal to 40 X1. So now, with these constraints, they have to be added to your other constraints that you originally wrote to have the complete model. Ladies and gentlemen, let me show you the complete model. If we go through the slides, you get to know how we calculated all of this. Okay. So this is a complete model. This is a final complete model. Because these y's are on the right-hand side, I can bring them to the left-hand side so that this rather becomes the final complete model. This is your complete integer programming problem. Once you're able to do this, you have created 25 banks for yourself. Now, suppose you solve this, and I did solve this correct model, and these were the answers. Watch the answers. What does this tell you? What does this tell you? This final answer. What does it really tell you? Okay. It just goes to show that our final Z function is 75 profit, and we are producing only pants machinery. So we are only producing 25 units of pants. And therefore we have to only incur the pant machinery. So you can see that the Y3 is 1. We've only incurred the pant machinery. If you go and check the pant machinery cost, it is 100. So Y3 is 1. Okay. So we incur a pant machinery of 100 and produce only pants. So we don't produce shirts. We don't produce shorts. We maximize our problem. We maximize our objective function value with 75. That is how we tackle this. And like I said, oh no, I think I mentioned 100, but it's supposed to be 200. If we make any shirt at all, because we are told not to make shirts here, no matter how many shirts we make, we must pay, the fixed charge of 200 to rent a shirt machinery. Okay, that's what we got to do. I think it's supposed to be pants, isn't it? I want to believe that it's pants. And a pant is supposed to be 100, I guess. The third one, Y3, and then X3. So that is how you got to do it. I solved it in Excel here, as you can see, and that is how I got a result. So if you go try it, you'll be able to get this sort of result in this concept. It's very easy to formulate and use an integer programming. There are other ones like the employee scheduling. Okay, try it on your own, and then we will be able to now get into the nitty-gritties again. All right, I hope you've enjoyed the lecture. Any question?